Distinguished future physicians, welcome to Stomp on Step 1, the only free video series that helps you study more efficiently by focusing on the highest yield material. In this video, we're going to be covering standard deviation and the measures of central tendency, which are mean, median, and mode. This is the first video of my biostats section, so I suggest you check out the rest of these when you're done with this video.
We'll get started here with the measures of central tendency. It might seem a bit weird to cover this topic for step 1. Most of us probably learned this for the first time in middle school, but it does show up on the step 1 exam sometimes, so I want to make sure we cover it. And the three terms are all pretty similar, so it's easy to confuse them. So doing a quick review couldn't hurt. The mean or average, you can see here in the top right corner that I give it a high yield rating of 2. The high yield rating is a score from 1 to 10, giving it estimated level of importance for step 1. If you want to learn more about the high yield rating, go to my website. The mean or average is just the sum of all the values divided by the total number of values. And it's important to remember that the mean is the least robust of the three measures. And if you're not quite sure what that is, just hold off for a couple slides because I'm going to cover that in more detail. To practice calculating mean, what is the mean of these 6 values? Basically, you just add up the 6 values and divide by 6, so you get something like 4.8. The next measure of central tendency is median, which can just be thought of as the middle value. And the median is the value that is in the middle when you arrange all of the values in ascending order. And the median is in between the two others with regard to how robust it is. What would be the median of these 6 values? You look for what's in the middle of them since they're already arranged in ascending order, and you can see that this is a data set with an even number of values. In this case, there really is no middle value, so what you do is you take the average of the 2 middle values. The average of 3 and 5 is 4. The last measure of central tendency is mode, which can just be thought of as the most frequent value, and it's the value that appears the highest number of times in the data set. And it is the most robust of the 3. To illustrate how to calculate mode, what would be the mode of these 6 values? Well, you look and you see that 3 is on there twice, and the other ones are only on there once, so the mode is 3. Now let's redo all those 3 calculations with the original 6 data points that I've been using over and over again, but now add in a 7th point of 100. So that would be an outlier. It's an extremely high value when compared to the other ones. How much does adding that one really weird value change the 3 measurements? And you can see that the mean changes a ton. It goes from 4.8, which we calculated before, all the way up to 22. So that's a huge change. The median increases from 4 that we calculated before to 5. And the mode is the same in both cases. What I'm trying to illustrate here is that just one or a couple values added to a data set, if they're extreme, can have a huge impact on mean, can have some of an impact on median, and almost no impact on mode. Previous question that we just did illustrates robustness, which I'm not really sure is a word, but I'm going to make it a word for this. Being robust is when the measurement is resistant to change by an extreme value. The mode is the most robust, median is somewhere in the middle, and then mean is the least robust. Now that we have covered mean, median, and mode, we can apply what we've learned to histograms. We'll start off here with the easiest one. This is a histogram of data that's normally distributed, so that means when you look at the histogram, the left and right sides are a mirror image of each other. And in these cases, the mean, median, and mode are all the same value. They're all here at the highest point. Another shape of the histogram that you see often would be skewed left, which is also referred to as negative skew. This kind of looks like you took a normally distributed graph and sort of stretched it out to the left, or took a normally distributed graph and added a couple really low values. which kind of distort it a little bit. So in these cases, the mode is higher than the median, which is higher than the mean. The opposite would be skewed right, or positive skew. This is when that tail is to the right side. It looks like a stretched, normally distributed graph out to the right. And in these cases, the mode is less than the median, which is less than the mean. Now we can move on to standard deviation, which is given the symbol of sigma, which you can see there. Standard deviation is how much the values in a data set differ from the mean. What's the variability or dispersion of the values in the data set? If you have a data set with a lot of similar values, they'll have a very low standard deviation. And if you have a data set with very different values, it'll have a high standard deviation. You can see that graphically with different histograms. This histogram on the left has a higher standard deviation because you can see there's a lot of different values spread out across, and they vary a lot more. But on the right, almost all the values are virtually identical, so there's very low standard of deviation. The last thing you need to know about standard deviation is how standard deviation changes in responses to sample size, or n. In small sample sizes, chance plays a bigger role in what you're seeing, so it has a bigger impact. In general, standard deviation of a small sample size is higher. As you increase the sample size, chance plays a smaller role, and you end up with a smaller standard deviation. That's not always the case, but more often than not. This is kind of like how the confidence interval changes in response to differences in sample size. The last thing about standard deviation is it can be used to measure how extreme one particular data point is when compared with the rest of the data set, if it's normally distributed. If it's normally distributed, 68% of the values are within one standard deviation, 95% of the values are within two standard deviations, and 99.7% are within 3 standard deviations. But this is really low yield for step 1, so I'm just going to skip over this topic.
Here are a list of related topics that are low yield enough that you really shouldn't focus on them until you've mastered all of the high yield material.
That brings us to the end of this video. If you liked it and want me to make more of these, please tell your friends and classmates about Stomp on Step 1. I don't have the resources to do any sort of advertising, and I don't have the time to really dive into anything like social media marketing, so the only way people are going to find out about these videos is by you, the viewers, so please do pass that on. Thanks, and good luck with the rest of your studying.